Welcome to our fifth and final video in our five-part video series on multiple linear regression with interaction. Let's take a look at what we've covered so far. In the theory video, Griselda said that we wanted to provide you the foundation to reach the peak of the pyramid, which is multiple linear regression with the interaction term included. Congratulations, you finally reached the top. In our final regression model, MPG, the x1 variable, and cylinders, the x2 variable, are used to predict the y variable, horsepower, which is the response variable. Included in this model is also an interaction term, x1, x2, which indicated the interaction between MPG and cylinder. We were able to estimate the betas using R. We estimated beta 0 to be roughly negative 0.79, beta 1 to be 2.84, beta 2 to be 30.86, and beta 3 to be roughly negative 1.09. Looking at the graph, the interaction term results in lines with different slopes. The red line represents cars with 8 cylinders. The blue line represents cars with 4 cylinders. You can see that cars with 8 cylinders have a steeper slope than cars with 4 cylinders. Let's think of some ways we can use this model. Say you're interested in purchasing a 4-cylinder car with MPG 20. Using the model, we can see that we should expect to get roughly 56 horsepower from that car. What if instead you wanted to buy an 8-cylinder car with MPG 20? Once again, using the model, we should expect to get 65 horsepower from that car. This model would be very helpful in helping one decide how many cylinders they want in a car they're about to purchase. In our last video, Yamini walked us through the assumptions and how to check them in R. We checked linearity to see if there's a linear relationship between the outcome variable and the independent variables. Next, we checked for multicollinearity. We do not want to see variables that are too highly correlated with one another. In R, our VIF scores were smaller than 5, meaning there was no multicollinearity present. We also checked to see if our residuals were normally distributed by looking at the QQ norm plot and the Shapiro-Wilk test. Both of these tests showed us that the data is non-normal. We checked homoscedasticity with a scatter plot and with an NCV test in R. By looking at the scatter plot and the small PV values in the NCV test, we saw that the data is heteroscedastic, not homoscedastic. Finally, we checked autocorrelation with a Durbin-Watson test. This test ranges between 0 and 4, with the goal being to be as close to 2 as possible. We hope you've enjoyed learning all about multiple linear regression with interaction. Thanks for watching.